Alright, sorry I can't talk very loud, but I'm going to go through this study guide answer key with you. Hopefully it helps. Just email me if you have questions. Okay, so for our vocab stuff, we have, y'all know what an electron is. Negative subatomic particle in the electron cloud. Electromagnetic radiation is a form of energy that exhibits wave-like behavior and it travels through space. Wavelength is how we measure waves. A lot of times it's given in nanometers. Frequency is the number of waves that pass a point in a certain time. The emission spectrum is the spectrum of light released from excited atoms of an element. That's like what we saw in the flame test lab. We saw the different colors. That was the emission spectrum of those particular atoms. We know that valence electrons are in the outermost energy level. The octet rule is what it's the tendency of atoms to prefer to have 8 valence electrons or for their outer energy levels to be full. Ions are atoms and molecules that have charge because they've gained or lost electrons. The Lewis dot structures are the way to represent the element. Remember, you just write the element symbol and then dot the valence electrons around them. Okay, so electrons are negative subatomic particles, but they behave like waves because they have different amounts of energy and can have different frequencies. Electrons absorb and release energy in the form of electromagnetic radiation. Right, again, that's the emission spectrum. It changes colors. Oh, it got off. So speed of light is always constant, right? That's on your formula sheet. And wavelength and frequency will have an inverse relationship. So as one goes up, the other goes down. Okay, your electromagnetic spectrum. Remember, on the left, you've got the longer wavelength, lower frequency, lower energy, right? All your L's. On the right side, you've got the shorter wavelength, high frequency, high energy. Right, so electron in its ground state is on its normal energy level, just where it normally resides. Okay, excited state is when it gains energy and jumps up in energy level. And then as it goes back down, it releases that energy as the emission spectrum. Okay, atoms are stable when they have a full outer energy level of valence electrons. The noble gases are already stable because they're already full. Cations are positive because they lose electrons. They're typically metals. Anions gain electrons and have a negative charge, and they're typically non-metals, so on the left side of the periodic table. And again, these italicized objectives are just stuff that you need to be able to do on the test. You need to be able to look at two waves and tell me which one has a greater wavelength, frequency, or energy based on the electromagnetic spectrum. You need to be able to do the math for wavelength, frequency, and energy. And again, those formulas are all on your reference sheet. And you need to be able to draw the Lewis dot structure. Okay, so then for the practice questions, to find the frequency and energy of red light with a wavelength of 650 nanometers. So you need to go from nanometers to meters. So you divide there, so it would be 6.5 times 10 to the 7th meters. And then to find the frequency, you do the speed of light divided by the wavelength. Speed of light is 3.0 times 10 to the 8th. Again, when I put this over into my recording app, I kind of jumbled everything up. But it should be 10 to the 8th power, then 10 to the negative 7th power. Those should be exponents. So your answer there is 4.6 times 10 to the 14th hertz. Right, remember that hertz is the unit for frequency. And then energy, you do, so then for energy you take Planck's constant, which is the 6.626 times 10 to the negative 34 times the frequency, and you get the energy. Remember, energy is measured in joules. So again, really, as long as you have your reference sheet, remember that you've got to convert that out of nanometers. So just move your decimal point 9 places to the left. Okay, so the Bohr model of sulfur, right? So for the Bohr model, you draw the nucleus, put the symbol, tell me how many protons and neutrons, draw your energy levels, and then fill in your electrons. But for the Lewis structure, which is on the right, you just put the symbol for sulfur, and yeah, it should have 6 valence electrons, so let's add one because mine's in good copy. I don't have my pencil either, guys, so that beautiful. So remember, you fill 1, 2, 3, 4. So you want one on each side before you start pairing them off. So 1, 2, 3, 4, 5, 6. Alright, so every side should have at least one before you start pairing them up. Okay, and then we talked about electron configurations in concept 2. We talked about quantum theory, where theory is equal to the wavelength of electrons. We talked about the orbitals, which are the 3D regions around the nucleus. Show you where the electron probably is, so it kind of like breaks down your shell a little bit into subsections almost. Then the electron configurations, the most stable regions of the electron in the electron cloud. Bohr's model shows the arrangement of protons, neutrons, electrons. It doesn't show it three-dimensionally, which is how we know it to be now. And it doesn't, the Bohr model shows that they would end it while they actually do not. It will ask you about the quantum numbers. So your principal quantum number, your angular quantum number, magnetic quantum number, and the spin quantum number. It'll ask you kind of where it is or what it describes. So just make sure you know that. So the first 3 shells of the electron cloud. So shell 1 can hold 2 electrons, and it has 1 orbital, which is an s orbital, right? So we do 1s2 first. Shell 2 can hold 8. It has an s orbital and a p orbital. Remember, s can hold 2, p holds 6. And shell 3 can hold 18. So we have 3 orbitals, an s orbital with 2, a p orbital with 6, and a d orbital with up to 10. So the 3 laws that explain the electron configuration are the Aufbau principle, Hund's rule, and the Pauli exclusion principle. Alright, so we know that they fill the lowest energy orbital first. Orbitals of equal energy get 1 electron before any orbital gets a second pair. And we know that no 2 electrons in the atom can have the same set of quantum numbers. Okay, so the first 3 periods are pretty easy, and then in that 4th period and further down, you've got those transition metals. So it seems like the electrons fill out of order because they're filling in order of energy, and so you've got some overlap in those larger atoms. So that's why those electron configurations get a little funky. Right, again, make sure you know your S, P, D, and F blocks on your periodic table. Make sure you know how they work for the electron configurations. You need to be able to write the electron configuration for an atom. You'll have your periodic tables for reference. You need to know how to do the regular electron configuration notation and the correct noble gas notation. Alright, so again, so all my subscripts are subscripts, superscripts. It's all messed up. But alright, so again, remember that second number should be like an exponent. So like for beryllium, again, don't have my pencil. So 1s2, 2s2. Right, so you fill 1s and then 2s for beryllium. And then the next is helium and then 2s2. chlorine, you have 1s2, 2s2, 2p6, 3s2, and 3p5, right? So chlorine only has, you don't have to fill 3p all the way to 6 because it doesn't have that many valence electrons, right? And then for the noble gas notation, remember you jump to the closest noble gas before chlorine, which would be neon. And then you know from looking at your periodic table, neon ends at, I have to pull it out periodic table. Right, so neon is at 2p6. So you just fill in everything after for chlorine. So that's the 3s2, 3p5. So nickel, you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Right, so right before nickel is argon. Right, and argon ends at 3p6. Right, and you can find that on the periodic table because argon's in the p block and it's in the third period. And iodine is cut off. I will make sure and send you guys another copy of this that doesn't have the cutoff part, but that way you can double check it. But if you have questions on how to do electron configurations, please email me before your test tomorrow. Right, and so we know that periodic trends are the patterns in the periodic table that make it possible to make predictions. Coulomb's law tells us that as the atomic number increases, the attraction for electrons increases, pulling the electrons in more tightly to the nucleus, right? Which makes sense because atomic number increases means that protons increase, and protons increasing means the positive charge increases. So it's going to more strongly attract the electrons. Atomic radius is half the distance between the nuclei of two identical atoms bonded together. Reactivity is how readily it will react. The shielding effect happens when electrons in the energy levels block the ones on the outer level from attracting to the nucleus. Okay, and we talked a lot about electronegativity, which measures the ability of an atom in a bond to attract electrons. We talked a little bit about ionization energy required to remove an electron from a neutral atom of an element, oxidation numbers, which are on my big periodic table if you need to look at it, but it's the charge of an ion, and the ionic radius is the radius of a monoatomic ion in an ionic compound. Lots of stuff on here. Okay, yeah, so this is what I was just explaining about Coulomb's law on the last slide. Right, again, it all is about how tightly the electrons are held to the nucleus. Alright, so atomic radius increases as you move left or down across the periodic table. Okay, reactivity increases down and right and decreases left and up on the right side, and on the left side it's backwards. That part I made it very clear in the Quizlet if you want to look at it. Okay, electronegativity. Again, if you want to draw the errors on your periodic table, you can, or on your cheat sheet. Ionization energy. So ionic radii are atoms that lose electrons become smaller. They gain electrons that become larger. It increases as you go down a group. This talks about the shielding effect. And then you need to be able, like we did on that worksheet the other day, to predict the type of bond that can form by looking at the difference in the electronegativities, which is your delta E in there. right? So you know that it's ionic if it's bigger than 2. It's covalent if it's less than 0.5, and anything in between there is polar covalent. Oxygen numbers, so group 1 is +1, group 2 is +2, 13 is +3, 14 is ±4, 15 is -3, 16 is -2, and 17 is -1. Right, so make predictions on how group elements will behave based on their location, so atomic radii, electronegativity, reactivity, things of that nature. Know that a cation is positive, anion is negative, things like that. Alright, so that's all. I think you guys will do more than fine on this test. Like I said, if you don't finish tomorrow, you can finish up on Monday. If you want to be able to skip a question on your test, be sure that your study guide gets turned into the bucket before class, or that it is in my inbox before 2:25 p.m. tomorrow. Alright, love you guys. Good luck.